7 million years ago, the African continent looked vastly different than it does today. It was a world in transition, a lush and dangerous tapestry of dense rainforests, shifting woodlands, and expanding lakes. Somewhere in this prehistoric landscape, a momentous evolutionary split was taking place.
This was the era when the lineage of great apes divided. One branch would eventually lead to modern chimpanzees and bonobos. The other would embark on a perilous journey of transformation, leading, ultimately, to us.
At the moment of this split, nothing guaranteed that our branch would survive. For millions of years, our ancestors were not special, not dominant, and not destined to succeed. They were just one fragile experiment among many, shaped by chance as much as by adaptation. For decades, scientists searched for the missing link, a singular creature connecting apes and humans. But the fossil record has revealed something far more complex, not a straight line, but a bush of diverse experiments in being human. To understand our origins, we must look at the three earliest known contenders for the title of first hominin: Sahelanthropus tchadensis, Orrorin tugenensis, and Ardipithecus ramidus. These are the pioneers of the human story. Our journey begins in the Jurab Desert of northern Chad. Today, it is an arid wasteland of shifting sand and wind. But 7 million years ago, this was the shore of a giant ancient lake, Lake Megachad. In 2001, a team led by Michel Brunet made a discovery here that shocked the scientific world. They found a cranium deformed by time and pressure, but unmistakably significant. They named it Toumaï, meaning hope of life in the local Goran language. Sahelanthropus tchadensis dates back to roughly 7 million years ago. This timing places it right at the split between the chimpanzee and human lineages. But was it an ape, or was it an ancestor? When fossil evidence is scarce, the skull becomes a map. Every ridge, curve, and opening holds clues about posture, diet, and behavior. For early hominins, a single skull can carry the weight of an entire species. The evidence lies in the anatomy. Although the brain case is small, similar to a chimpanzee's, the face is surprisingly flat. More importantly, the canines are reduced and worn at the tip, distinct from the sharp, self-sharpening fangs of male apes. The most controversial and critical clue, however, is the foramen magnum, the hole where the spinal cord exits the skull. In apes, this hole is at the back, for walking on all fours. In Toumaï, it is positioned further forward.
This placement suggests that Sahelanthropus held its head upright, sitting atop a vertical spine. This is the hallmark of bipedalism. Toumaï may have been the first of our kind to walk on two legs.
If Sahelanthropus was truly upright, then one thing becomes clear. Walking on two legs came long before intelligence, language, or technology. We stood up while our minds were still primitive. However, without limb bones, no femur, no pelvis, we cannot be 100% certain how Toumaï moved. Some critics argue the skull was deformed, or that it represents an extinct female ape. The debate remains one of the hottest in paleoanthropology. Leaving the deserts of Chad, we travel southeast to the Tugen Hills of Kenya. Here, in sediments dating back 6 million years, we find our next candidate, Orrorin tugenensis.
Discovered in 2000, Orrorin is often called the Millennium Man. Unlike Sahelanthropus, where we have a skull but no legs, with Orrorin we have the opposite: fragmentary jaws, teeth, and crucially, a femur, a thigh bone. This single bone tells a powerful story. The neck of the femur is elongated and reinforced with bone on the underside. This specific anatomy is an adaptation to bear weight on an upright torso.
While the femur screams biped, The rest of Orrorin suggests life in the trees. The arm bones differ from ours, and the curved finger bones indicate powerful grasping capabilities. Orrorin was likely at home in two worlds.
Orrorin lived during a time of dramatic environmental instability. Forests expanded and contracted. Seasons became harsher. Survival favored flexibility, not specialization. Being able to climb and walk was not a flaw, it was an advantage.
The teeth of Orrorin also provide clues. They are smaller than those of ancient apes with thick enamel. This suggests a diet not just of soft fruit, but potentially tougher foods like nuts, roots, or tubers, a diet for a changing environment. Orrorin reinforces the idea that bipedalism didn't happen overnight. It likely evolved in the trees first, perhaps to reach fruit on terminal branches, before it became a way to travel across the ground.
Now, we jump forward in time to 4.4 million years ago. We travel to the Middle Awash region of Ethiopia. Here, we meet the most complete and perhaps the most surprising of the early hominins, Ardipithecus ramidus.
For 15 years, paleoanthropologist Tim White and his team worked in secrecy, painstakingly piecing together a skeleton they nicknamed Ardi. When unveiled in 2009, she changed everything we thought we knew. Ardi is a mosaic of anatomy that defies simple categorization. She stood about 4 feet tall and weighed around 110 pounds, but it's her feet that shocked the experts.
Ardi possessed an opposable big toe, jutting out to the side like a thumb. This is a feature for grasping branches, typical of tree-dwelling apes. Yet the rest of her foot was stiff, structured for pushing off the ground. This means Ardi was a facultative biped. She could walk upright on the ground, though not as efficiently as we do, but she was still a master climber. She was not a knuckle walker like a chimp.
For decades, scientists assumed that humans evolved from a knuckle-walking ancestor like modern chimpanzees. Ardi forces us to reconsider. Perhaps chimpanzees are not living fossils, but specialists of their own path. Her pelvis confirms this duality. The upper blades are short and broad, supporting the lower back for upright walking. But the lower pelvis is ape-like, housing the large muscles needed for climbing. Ardi's hands were also revealing. They lacked the stiffness and special ridges required for knuckle walking. This suggests that the common ancestor we share with chimps was not a knuckle walker at all. This shattered the Savanna hypothesis, the old idea that our ancestors stood up because the forests disappeared. Ardi lived in a woodland, surrounded by trees, monkeys, and peacocks. She stood up while still living in the forest.
Like Sahelanthropus, Ardipithecus's canines were small. In primates, large canines are weapons used by males to fight for dominance. Small canines in Ardipithecus suggest a major shift in social behavior. Owen Lovejoy, a lead researcher on the project, proposed that this signals the beginning of pair bonding. Males may have begun provisioning females with food in exchange for mating exclusivity, reducing the need for aggressive competition. So what do these three species, Sahelanthropus, Orrorin, and Ardipithecus, tell us about the dawn of humanity? They tell us that our evolution was not a march of progress, but a mosaic of adaptations. We see that bipedalism came first, long before big brains or stone tools. We see that we stood up in the safety of the trees, not the danger of the open grass. And we see that our separation from the apes was gradual and complex. Ardipithecus eventually vanished, likely giving way to the Australopithecines, the genus that would include the famous Lucy. But without these earlier pioneers, the human story would never have begun. These fossils are the only physical connection we have to those 7 million years of silence. They are the first chapters of our autobiography, written in stone and bone, waiting for us to read them. Thanks for joining us on this journey into deep time.
If you want to explore more about human evolution, make sure to subscribe and let us know in the comments which ancestor fascinates you the most.